As we continue and complete Chapter 7, our last topic is the complex numbers. So we'll be dealing with them and adding and subtracting, multiplication. We're going to talk about conjugates and divisions and then powers of I. So let's take a look at the words for fill-ins from 1 through 4. So some important things to note that we will be defining in this section the square root of -1 as the lowercase letter I. Watch what happens if we square lowercase letter I, which is -1. So we take away the radical sign. Remember, there's a 2 there. We're going to place that 2 under the 2. This cancels out and we're left with 1. And that is -1. So -1 is I squared. So this is something we're going to use quite extensively in this section, where I squared is defined as -1. The square root of -1 is I. I squared is -1. And this is the proof of it. Now, when we write I in connection with real numbers, the standard form for writing it is this: A, which is the real number, B, which is a number, and then times I. Okay? We'll be getting back to that too. Now, imaginary numbers, while the name might sound like they're somewhere out there, are not really imaginary. They are numbers. They're just not real numbers. And if we take the imaginary numbers and the real numbers we've talked about, they make up a group called complex numbers, which again are written in this standard form, where A is the real part and this is the imaginary part. Now, another thing we're going to use as we go through some of this is the conjugate. Now, you recall the conjugate from earlier lessons, where you have two terms, one with a plus, one with a minus, and when you multiply them, the middle terms cancel out. So we're going to use conjugates to convert from imaginary numbers to real numbers, as you'll see later on. So this is your imaginary or complex number conjugate, where we just stick a lowercase I in there for the imaginary part. Okay, let's go on. Now, for all of these, we're going to convert them from this form by taking out an I, which is a square root of -1, and just put this there. See how easy that is? And there's an 8 minus I, the square root of 150. Now you might think you're through, but no, not really. Because over here, now the square root of 49 is 7. So you could write it I7. Most of the times we write it 7I. This one is as far as you can go. You recall we did 200 before, which was 10I, the square root of 2. We said 200 is 10 the square root of 2. But now we have to stick the I in there. And this one is going to be negative. Now this is 9 times 5. So negative 9I, the square root of 5. And 150, does that have a square in there? Yes, let's just do that one. So here we take the 150 and divide it into a perfect square factor of 25 times 6. This comes out as a 5, and we write it as that. Notice this is in the form of a complex number, a plus bi. Okay, we'll go on. Before we go on, I forgot to take the square root of that 9. So that should have been a 3 there. Okay, any of you who spotted that for a bonus point, you tell me about it and I'll give you the bonus point. Okay, now we can go on. So doing number 10, again we take the I out, that takes care of the negative. Then we're left with 32. Is there a perfect square factor? Yes, 16. So this is going to become I, 4I, the square root of 2, minus 3I. Now keep in mind these are not like terms, so I can't go any further than that for number 10. Okay, now we're doing some addition and maybe later some subtraction. The nice part about this is that we just collect like terms. This is going to be a 12. Collect like terms plus 3I. Now notice that's in standard form, a plus bi. So 5 and 11 are 16. A negative 7 and a 4 is a negative 3I. Now here we're going to use our rule where this becomes positive, this will become negative, and that will be positive. So 3 minus now 6 is going to be a negative 3, and a negative 8 and a positive 2 is a negative 6I. Now as we do this next part, again this will become plus, then that'll be minus, and this will be plus. So negative 2, negative 9 is negative 11. Then a negative 5 and a plus 7 is a plus 2I in standard form. Okay, now we're going on to multiply. And again, the very same rules apply. 8 times 11 is a negative, let me see, that's a positive. I'm thinking ahead here. 88. I times I is I squared. But we define I squared as a negative 1. So in an answer, you would never leave an I squared. You always have to plug in there a negative 1. So this becomes a negative 88. See, I was thinking ahead. Now, when you do this, watch what you have to do. For this first term, take out the I. And then now that's the square root of 100. Times, take out the I. That's the square root now of 81. You can't multiply these negative signs like we did. That doesn't apply to complex or imaginary numbers. So now we go I times I is I squared. Now we know this is going to be 10, and this is going to be 9. So then we get and remember this is a negative here. This will become a negative 90 is your answer. And that's how you did it. Again, you have to take out the negative first as the I. Then you multiply the i's to get a negative, I squared, which is a negative 1. Okay. Now these work the same way. We're going to distribute. So this is going to be 10i, and this is going to be a minus 8i squared. But we said I squared is negative 1. So this becomes a positive 8 plus 10i. Now why did I switch the order? Well, because the way to write complex numbers in the form of a plus bi. Now, on a paper test I would have taken it the other way, but MathLab is going to be critical. You have to put it in standard form. Working these now, we're going to distribute, watching the signs, a negative 18i plus 3i squared. But we know I squared is a negative 1. So this then becomes a negative 3 minus 18i. The proper way to put it in standard form. Now, for this next one, we're going to FOIL. And this is good because we haven't done foiling for a while. So let's just do it. FOIL these gives us a negative 10. My outers now give me a negative 12i. Now you can do this mentally also. This is a 15i. And then this is going to be a positive 18i squared. But we know that I squared is a negative 1. So this becomes a negative 18 and a negative 10 give me a negative 28. And then this, when we combine like terms, gives me a positive 3i, and that is in standard form. Foiling, that's a positive 21. Outers is a negative 28i. Inners a negative 9i. And last, a positive 12i squared. But we know that I squared is a negative 1. So, for this one, this will leave me with a 9 all by itself minus $37i. And that's in standard form. Again, this I squared, never leave an I squared. I squared is negative 1, so the sign reverses usually. Now for 21, we're going to square this binomial, square the first term, that gives you 16. Multiply these two together, that's going to give you a 28, negative 28, double it, that's going to be a negative 56i. Square this last term, that's going to be a positive 49i I squared. But I squared is a negative 1. So for this one, a negative 49 and this gives me a negative 33 minus 56i. Square this binomial. Square the first term. That gives you 100. Multiply these together. That gives you 30i, double it, 60i. Square the last term, plus 9i squared. But we know I squared is a negative 1, so this is a negative 9. This then is 91 plus 60i. Okay. Now here they want us to simplify and put this into standard form. And to do this, we will multiply the denominator by its conjugate. So, what is the conjugate of this? Think about it for a moment, and it's the same items, but the opposite sign. Now, this is 1. We are allowed to multiply this by 1. Doesn't change its value, but it gets the I out of the denominator. So, this is going to be 2 times 2 is 4. A negative I times a positive I is a negative I squared. And we'll get back to that in a moment. And then here we get a 6 minus 3i. What do we know that I squared is? It's a negative 1. So a negative of a negative 1 makes this a denominator now of 4 plus 1, that is 5. Now technically that's the answer, but if you put that in the math lab, they'll probably count it wrong because it's not in standard form. So you then put it in standard form by putting it over each of these denominators here. Now in some cases we can simplify, but not here. So this is the answer. Now I see that some books use a slightly different technique. I'm just going to multiply this and this by a negative I. Remember, that's 1. The same thing here. This and this by a negative I. And this one, we would use the imaginary conjugate. That would be 5 plus 3i. Opposite signs. Now these are all my 1s. So here, this then becomes 5, a negative 5, I squared. And my numerator becomes a negative 11i. Now, notice I squared is what? A negative 1. So this changes its sign. The top is still a negative 11i, but the bottom now becomes a positive 5. Okay? Now you might say, wait, negative divided by a negative. No, remember, you have to do this first. Get that I squared is a -1, so this became a positive. Okay, let's do this one here. We'll do the bottom first. This is going to be a negative 2i squared. That's going to become a positive 2. And my top becomes 6i, a negative 6i, plus negative times negative now makes it a plus 5i squared. But again, this is not in the correct form yet. So here, this over here is going to be a -1. So this is going to become a -5, this one here, over 2. Now this is a negative 6i over 2. And notice here you can cancel out. This will be a 3, and this is going to become a 1. So I believe that's the final answer, and I'll check it. Yes, it is. And again, they don't have the work here. It's just -3i. The 2 is a 1, and we don't write that. Okay, let's FOIL our denominator here. 5 times 5 is 25. This times this is a -9i, but I squared, I should say. I squared is a -1, so this is going to become eventually a positive. And the I squared goes away. So our denominator here is 34. Now as we FOIL the top, that's going to give us a 15. My outers are a positive 9i. My inners a positive 10i. And my last a positive 6i squared. But we know I squared is a -1. So this is going to be a -6 here. And that gives me a 9. And I'm going to group these two together. Plus 19i. Again, if you put that in Math Lab, they're probably going to count it wrong. You need to separate it to put it in the a plus bi form. So that's 9 over 34 plus 19i over 34. Okay, almost finished. Now, I always like to give this little lesson here. We're talking about powers of I. So, what do we have here? We know that I equals I. And we know that I squared equals -1. Well, what does I to the third equal? Well, actually that's I to the second times I. Well, I to the second is a -1, so -1 times I is -I. And I to the fourth is I squared times I squared. -1 times -1 is a positive 1. So when we continue, what is I to the fifth? Well, I to the fifth is I to the fourth times I. This is 1 times I, which is I. I to the sixth is 1 times -1, which is -1. I to the seventh is I to the fourth times I to the third. This is I to the third times 1 is -I. And I to the eighth is I to the fourth times I to the fourth. And that's 1 times 1, which is 1. And this pattern repeats for every 4. So what you have to do is find out how many I to the fourths we have into something here. And these are all ones, I to the fourth. So what do we have here? Well, we have I to the fourth. See if I get my pen working. Times 11. I to the fourth is 1. 1 times 1 times 1, 11 times is 1. Now here we have a negative I. Now remember, anytime we have a negative to the 10th power, now I wanted to write this out for you. Anytime we have a negative that's raised to an even power, it's the same as if that were a positive I. So I to the 10th is I to the fourth times I to the fourth times I to the second. And these are all ones. And I to the second is a negative 1. So our answer here is negative 1. Now, here we have to raise 2 to the third power. That's 2 to the third power, I to the third power. We know I to the third power is negative I. So this is going to be a negative 8I. Because this here becomes a negative I times 8. Negative I times 8 is a negative 8I. Now this one is a 2 to the fifth, which is 32. I to the fifth, which we said was I, because that's I to the fourth, which is 1, times I. So number 30 is 32I. And again, your practice and homework will determine how well you do. And again, hopefully these have been helpful. We'll be moving on to Chapter 8.